Hey guys, it's Anika. Welcome back to my channel. Today I'll be solving the 2024 AP Calculus AB FRQs. Here is FRQ 2. A particle moves along the x-axis so that its velocity at time t is greater than or equal to 0 is given by v of t equals ln t squared minus 4t plus 5 minus 0.2t. There's one time t equals tr in the interval t is between 0 and 2 not equaling 0 and 2 when the particle is at rest. Find tr. For t between 0 and tr not including 0 and tr, is the particle moving to the right or to the left? Give a reason for your answer. So first, to find the time when the particle is at rest, we want to take the velocity and see when it's equal to 0. So the way we can do that is graph it on our graphing calculator, since the graphing calculator is allowed on this problem, and see where the graph hits the x-axis. So first, I'm going to plug it in to the calculator, and then we can graph it, and then you can hit second trace, and then you can find the 0 of the function. And so we can hit the left bound and then keep going right and hit the right bound. And since it's also asking for TR in between 0 and 2, we want to find the 0 that is greater than 0 but less than 2. And so since there's 2 points where the function hits the x-axis, it's going to be the first time, not the second time, since the second time is after 2 on the x-axis. And so as we can see, t equals this number, which is approximately 1.426. So this is equal to TR. Next, for t in between 0 and TR, we need to find if the particle is moving to the left or to the right. So how we can figure that out is by seeing if v of t, the velocity, is greater than or less than 0. If the velocity is positive, meaning it's greater than 0, that means that the particle is moving to the right. And if the velocity is less than 0, that means the particle is moving to the left. So as we can see, from 0 up to tr, which is this point, the function is above the x-axis, meaning that the velocity is greater than 0. And since the velocity is greater than 0 for t is in between 0 and tr, the particle is moving to the right. And so the question asks to give a reason for this answer, and so this is the reason. Part B. Find the acceleration of the particle at time t equals 1.5. Show the setup for your calculations. Is the speed of the particle increasing or decreasing at time t equals 1.5? Explain your reasoning. So first, to find the acceleration at time t equals 1.5, we need to find the derivative of the velocity at 1.5. And so for this, we can just plug this into the graphing calculator. So you'd click Math and N derive, which is number 8, d over dx, and then here you would plug in the function. And so you can over here retype the function that they gave, but since we already had put it in here for y1, we can just call y1. So what we would do is you click vars, yvars, function, and y1. And now that's a really easy way to just call the function that we had already typed in instead of having to retype it. And we're trying to find the derivative of the velocity at t equals 1.5, so we put 1.5 here. And now we get this answer, which is negative 0.99999, and some more numbers. So we can just simplify that to negative 1. Next, we want to find if the speed of the particle is increasing or decreasing at time t equals 1.5. So the way to do that is if the acceleration and velocity at that time have the same sign, that means that the speed is increasing, but if their signs are different, that means that the speed is decreasing. So we already know the acceleration at t equals 1.5, so now let's find the velocity. So for that, all we need to do is plug it into the function that they've given us, so we can use the graphing calculator for that. So now I'm going to plug in the equation for the velocity and then replace t with 1.5. And so we get negative 0.0769. And so as you can see, the velocity is less than 0, and so is the acceleration, meaning they both have the same sign, which also means the speed of the particle is increasing at time t equals 1.5. And so our reasoning for this would be the fact that the acceleration and velocity at 1.5 have the same sign. Part C. The position of the particle at time t is x of t, and its position at time t equals 1 is x of 1 equals negative 3. Find the position of the particle at time t equals 4. Show the setup for your calculations. So for this question, we're going to use something called the Fundamental Theorem of Calculus, or FTC for short. And so in this question, we're going to use FTC Part 1. And so how we're going to use this is by showing that the integral from 1 to 4 of v of t dt, v of t being the derivative of x of t, equals x of 4 minus x of 1. And so in this case, since we're trying to find x of 4, we're going to rewrite this as x of 4 equals x of 1 plus the integral from 1 to 4 of v of t dt. And so the question already gives us that x of 1 is negative 3, and then we can find the integral from 1 to 4 of v of t by plugging it into the calculator. So we can hit math, and then 9 for the integral, and then we're going to do from 1 to 4, and so since we already have v of t plugged in as y1, we're just going to put in y1 again. And of dx. And so we get 0.19712 approximately. And I'm not going to write out the full number, but we're just going to finish the rest of the calculations on the calculator so that it's the most accurate. So we're going to subtract 3. And then we get about negative 2.803. And so that is the position of the particle at time t equals 4. Part D. Find the total distance traveled by the particle over the interval t between 1 and 4, including 1 and 4. Show the setup for your calculations. So to find the total distance traveled over this interval, we basically want to find the area under the curve of the velocity. And to find that, you would take the integral of the velocity between 1 and 4. Now, since we're trying to find the distance always has to be a positive number, so we always want to put the integral of the absolute value of the velocity. And so now we can just plug this into the calculator. So like before, we would hit math, 9 for the integral, from 1 to 4. And then before we call y1 again, which is the velocity function, we want to first put absolute value signs. So the way to do that is to hit math, then you go to num, and then the first one, and then we can add y1. And now we get the total distance traveled to be about 0.958. Thank you so much for watching this video. You can check out my channel to see the rest of the FRQs. See y'all next time. Bye!